Okay, we're here with Rita to talk about solving systems of linear equations. Ready to go, Rita?
Yeah.
Okay, so first, what's a system? Well, a system is just when you have more than one of an equation. And so here in this case, we'll be talking about two, all right?
Okay.
And linear equations are just equations that create lines when you graph them. Okay, so we're going to be talking about situations where we have two lines. Okay?
Okay.
So let's look at graphing first, then we'll look at something called the substitution method, and then the elimination method. Okay, and when we graph, we'll see that there's really three possibilities when you have a system. Let's take a look at one of those possibilities. Okay, so one possibility is like this. You have two lines, and one is y equals negative 3x plus 6. You can see we've graphed that there. And the other one is y equals x plus 2. And you can see that they cross at a particular point, and that point is what?
1, 3.
Right. So let me ask you a question. What is the only point in the whole world that is true for both of those equations?
A 1 and a 3.
Right, 1, 3. X equals 1, y equals 3. It's the only point that solves both the equations. So it's called the solution of the system of equations. Okay, that's what we're talking about here. Now, so if there's two lines and they're on you graph them on the coordinate plane and they cross at a point, good. There's one solution, exactly one solution. Now, what about this situation though? Here's y equals 2x plus 6 and y equals 2x minus 1. Are those ever going to cross?
No.
They'll never cross, right? Because you can see that they both have the same slope. What's the slope?
The slope is the change of y over change of x.
Yeah, and in the equation, y equals mx plus b, it's m, right?
Yeah.
So the slope will be the coefficient of x. So in this case, what's the slope of these ones?
2.
2, right? So the slope of each of the lines is 2, so they're going to have the exact same angle to them, or slope, but they have different y-intercepts. One has a y-intercept of 6, so you can see that's the b in y equals mx plus b, and the other one has a y-intercept of what?
Negative 1.
Negative 1, right?
Mm-hmm.
So they're essentially parallel, right?
Yeah.
And parallel lines will never cross. So there's never a point that would solve both of those equations. So there's no solution. Okay? So when you have systems, it might be that there's no solution. And then there's one other situation you can run into. There's an equation y equals negative x plus 4, and then 2y equals negative 2x plus 8. If you graph those two lines, you'll realize they're the same line. The second line is just kind of disguised as the first line because it's the first line with everything multiplied by 2. Can you see that? The y becomes 2y, the negative x becomes negative 2x, and the 4 becomes 8.
Yeah.
So there are two lines that are kind of disguised, but they're really just one line. And every single point that you see on that line is a solution for both lines, right?
Right.
So that means that there are infinite solutions. So those are the three possibilities when you have a system. You can either have one solution, you can have no solutions, or you can have infinite solutions, okay?
Okay.
Now, graphing is tough. Even if you have like a graphing calculator or an online graphing tool, it can be tough to graph. You don't want to go to all that trouble. So there's a couple of methods that can get you to solutions easier. They're called the substitution method and the elimination method. So we're going to run through those right now. Okay?
Okay.
So let's say we have these two equations. So these two things together are called a system of linear equations. We can see that they're linear because they're in y equals mx plus b format. Okay? So the thing is that we can see that y equals 2x minus 3, but y also equals x minus 6. So we could say, well, if y equals that, then we can if y equals 2x minus 3 in the first equation, we can take that 2x minus 3 and we can substitute it in for y in the second equation. Does that make sense?
Yeah.
Okay, so let's rewrite that with that substituted in. So essentially what we've done here is just that substitution. We've taken this 2x minus 3 and we put it in for y. So now we have 2x minus 3 equals x minus 6. Make sense?
Yeah.
Now we can just go ahead and solve this. We'll go ahead and go through our steps here. We'll subtract x from both sides to get all of the variables on one side. That'll leave us with x minus 3. What would you do next?
Add 3 to both sides.
Good. We'll add 3 to both sides, and that'll get us to an answer of what? X equals?
Negative 3.
X equals negative 3. Good. Now, that's not our full solution, though, right? That's just the x value. What we're looking for is an ordered pair, an x value with a y value. Because remember, when we're looking for a solution, we're really looking for that point where the two lines cross. So we need both the x value and the y value. So we can take this x value and we can put it back into either of our first equations, and we'll get the y value for that, okay? The reason we can put it in either one, we can put it in this line or we can put it in this line, okay? Or these two lines, and it will get us to the same y value because it's the same point on both lines. So let's go ahead and substitute into one of the equations. We'll put it into, let's see, y equals x minus 6 to start, and then we'll put the negative 3 in there for the x. We're just substituting x there, and then that equals y equals negative 9. Now we can put it into the other equation too. So the other equation is y equals 2x minus 3. Put that negative 3 in for x. So we have y equals 2 times negative 3 minus 3. That is y equals negative 6 minus 3. And that is y equals negative 9. So isn't that great? They both come with the same y value. Now, so what is our solution? It's the ordered pair or the point where that is the solution to this system. So how would you express that solution? What is it?
Negative 3 and negative 9.
Yep, so it's the point negative 3, negative 9. Does that make sense?
Yeah.
Okay, and if we were to graph it, you would graph those lines and they would cross at the point negative 3, negative 9. Okay, let's go ahead and circle that answer. So that's the substitution method. Sometimes that's the easiest way to go. And you can use any method that you want when you're working with systems of linear equations. Sometimes you might want to graph it, but the substitution method is often really easy. Now another method, which is really cool, often it's easier, and then it also sets you up to do all sorts of cool stuff when you get to higher level method, is called the elimination method, okay? So let's go ahead and look at an example where the elimination method works really well. So one of the reasons this works well is that we're not in y equals mx plus b form right now. We're more in the standard form of a linear equation. So we have x plus y equals 7, and we have x minus y equals 11. Now, you could get this into y equals mx plus b form and then substitute in. That would be a fine way. You could use the substitution method. But let me show you what the elimination method is all about, okay? When we work with equations, you can always add the same amount to both sides of any equation, right? That's just a rule. So what we're going to do, and this might sound a little bit complicated at first, but once you get used to it, it's really easy, is we're going to say, okay, here's an equation, x plus y equals 7. I want to add something to the left side and to the right side of it. And that something has to be equal, right?
Right.
Okay, so to the left side, I'm going to add this. I'm going to add x minus y. And to the right side, I'm going to add 11. Okay, now those two things are equal. We see in the second equation they're equal, right? So I can do that, right?
Right.
Okay, so what I basically am doing when I do that is I'm adding the equations. Okay, so it looks like this. Now, remember, what we're really doing, though, is we're adding the same thing to both sides of the first equation. That's why we're allowed to do this. That's why it works with math. But eventually what you'll start thinking about is I'm just adding the two equations. Okay? Now what happens? What's x plus x?
2x.
Good. What's y minus y?
0.
0. So on the left side, we're only going to have 2x, right?
Yeah.
And then what's 7 plus 11?
18.
Okay, so what this results in is 2x equals 18. Easy to solve, right? So what would you do there, and what does x equal?
You divide both sides by 2, so x equals 9.
Okay, good. So x equals 9. Excellent. Okay, now we always have to go back and substitute in to either equation, right, to find what y equals. Right. So let's go ahead and substitute into that first equation. 9, or x plus y equals 7, so we'll do 9 plus y equals 7. And then, so what does y equal there?
Negative 2.
Good, because you subtract 9 from both sides, and you get y equals negative 2. So what's the solution to this system?
The point 9 minus 2.
Yep, 9 negative 2 is the solution, okay? Now remember, the reason we could do this is because we are allowed to add the same thing to both sides of any equation, okay? Now, this one was really set up to do it because you had a y and a negative y. Sometimes it's not going to be so easy for you. You might have to adjust one of the equations first. So let's look at another example here. We have 2x minus 3y equals negative 11, and then you have x plus y equals 7. Now, if you were to add these, it wouldn't get rid of the x's, right? Because 2x plus x is 3x. And it also wouldn't get rid of the y's, unfortunately. But what if you took that second equation and you multiplied it by 3. Okay, the whole equation. Then this multiplied by 3 is 3x plus 3y equals 21, which I've written right here. Okay, now this should look pretty attractive because kind of like up here, that y can just fall out of the picture because negative 3y plus 3y makes it go away, right? So now we can add those equations just like we did before. So what will we have on the left side?
5x.
Good, and then the y's will go away, right?
Yeah, the y's go away.
And what will we have on the right side?
10.
Yep, negative 11 plus 21 is 10. So we have 5x equals 10. So what does x equal then?
2.
2, good, because we divided both sides by 5. Now we can go ahead and substitute back into either equation. So we'll go ahead and use that easiest equation, x plus y equals 7, and we'll do 2 plus y equals 7. So what does y equal?
5.
5, because we subtract 2 from both sides, okay? And so what is our solution to this system of linear equations?
2, 5.
2, 5, right? So here we have learned a couple of things then. So we've learned that there's 3 possibilities. There's one solution, no solution if they're parallel, or infinite solutions if they're really the same line. And then if it's easy, use the substitution method. And if the elimination method, if you can use that, that's sometimes really cool and the easiest way to get at it. Okay, does that make sense?
Yeah.
All right, excellent work. Good job.